Well, hi there, boys and girls. Today we're going to do one of my favorite lessons of the year, volumes by discs and washers. And tomorrow in class I'm going to develop some formulas for you, but today on the video I'm just going to give you the formulas. First of all, you're going to have to figure out if your volume has a hole or not. Now we're going to start the first example with no hole in the graph at all. And the concept is we're going to be taking a graph, or an outline of a graph, and we're going to be rotating it around an axis. I'll show you this tomorrow in class, and I'll also show you on my wind plot program here. But your volume is going to equal pi times the integral from a to b of f of x squared dx. This is if there is going to be no hole. Let's talk about what I mean by no hole. What if I have this graph here in red and I revolve that around the x-axis and I spin it around the x-axis? If I do that, and you take any little cross section here and you spin that around, there's no hole between the graph and the axis of revolution. Therefore, this graph is going to be solid. That would look somewhat like a cup or something like that. So there's not going to be a hole. So we're going to just use the volume equals pi times the integral from a to b of f of x squared dx. Okay, so let's just keep going with this. So what if we were to take this graph of y equals 3x and we were going to look between 0 and 1 and the x-axis. So here's our region. And what if we took that graph, that region, this region R, and we spun it around the x-axis? What would it look like? Well, hopefully you can tell that it would look like a cone, and this is what that graph would look like. Let's go take a look at wind plot and see that. Here is y equals 3x drawn between 0 and 1. And what I want to do is I want to revolve that surface, and I'm going to revolve that surface between 0 and 1, and I'm going to do around that line y equals, or I'll just say x-axis here. And I'm going to do something here on my wind plot program so I'll be able to show you something. Just doing at A. Okay, so I'm going to do C surface here, and I want to see my x, y, and z axis. So here is what that graph would look like if you were to rotate it around the x-axis. And what I want to do is I want to find the volume of this cone. And we're going to come back here to my animate here. I'm going to see what happened. What happened was we took that line and we started spinning it around the x-axis, and we spun it all the way around 360 degrees, or in my instance I had 6.28, that's 2 pi. And we want to find the volume of this cone. Well, the formula is pi times f of x squared dx, and that's how you find that volume. Alright, so let's do a specific example. Let's do 3x squared, and we're going to find the volume between 2 and 5 using the formula. Now, y equals 3x squared, you know, is this quadratic, and we want to look between 2 and 5. So let's draw a little axis here for us. Okay, so we're going to look between x equals 2 and x equals 5. And so we have this region here. And we're going to take this entire region and we're going to spin it around the x-axis. And we want to find that volume. So we use our formula. Our formula is, and by the way, is there any space between the axis of revolution and this region? No, there's not any space. So we just do pi times the integral from 2 to 5, because those were our x limits of integration, of f of x squared dx. So if I take 3x squared and square it, what am I going to get? So my volume is going to be pi times the integral from 2 to 5 of 9x to the 4th dx. So I took 3x squared and I squared that. And we're now going to integrate that between 2 and 5. So this is what our little volume should look like. The pi can go out front or in there. Remember, the constant can move in and out of an integral. Alright, so let's go here and do this math. We had pi integral from 2 to 5 of 9x to the 4th dx. So the first thing we do is we find an antiderivative. So I'm going to do 9x to the 5th over 5. And I'm going to evaluate this between 2 and 5. And I'm going to have a pi out here in front. So I'm going to have 9 times 5 to the 5th over 5 minus 9 times 2 to the 5th over 5, and I'm going to have a pi in front of all of that. And if I happen to know what 5 to the 5th is off the top of my head, that'd be pretty amazing, but I don't know that. So I'll probably finish that on a calculator. 5 cubed, yeah, we're just not doing that right now. Anyway, so that would be the volume of that. Okay, so let's go now take a look at what if we have a hole. If you have a hole, you need to find an outside radius and an inside radius, and our volume is going to be pi times the integral from a to b of outside radius squared minus inside radius squared. Please notice that this is not the same thing as the two things subtracted and then squared. For example, this, get a little squared on it, that's a squared up here. This does not equal capital R of x minus little r of x squared. I have spent a lot of time in 18 years of teaching convincing kids that a squared minus b squared does not equal a minus b quantity squared. That is not a true statement. So this is your volume formula that I'll be using. And so we're going to take a look at this. Here I have a region defined above by the square root of x and below by x squared. And I want to revolve this around the x-axis. Notice that my region has some space. There is some space in here. There's a hole between my region and my axis of revolution. If that is the case, you're going to have to do what's called the washer method. Now let's go take a look at this picture with my little wind plot. So I've got I'm going to close this, and I'm going to delete that equation. So we're going to do an equation. We're going to have y equals square root of x. And we're going to lock this interval between 0 and 1. And then I'm going to have another equation, which is going to be x squared. Lock that interval between 0 and 1. So that's what I'm going to spin around the x-axis. Alright, so let's go out here and let's do revolve surface. I'll revolve that square root of x from 0 to 1. I'm revolving around the x-axis, and then I'm going to do this little at a thingy so we can see this. So there's the surface as we take the square root of x and revolve it around. We'll get on here, throw my axis on there, that's what it's going to look like. Then I want to come back here and also do x squared, and I'm going to see that surface. And so what you have, let me get on here, sorry. Here, this is what our little solid would look like. Now let's see this animation. So I'm going to come down here to A, and we're going to see how this happened. So we started with this little region in the x and y axis. I've got 3D graphed here, but the x and y axis, and we started spinning that region around the x-axis. And as you can see, there's a hole in our solid because of that space between the x-axis and our region. And so we are going to find the volume of that. And the basic idea is to find the volume of the outside one and then subtract the volume of the inside one. So that's what we're doing. So let's come back here and do that. So here is our formula. Let me come down here. We are going to figure out what the outside radius is and what the inside radius is. And so the outside radius is the distance from your axis of revolution to the curve that's on top. And so this is my outside radius, and it equals the square root of x. My inside radius is the distance from the bottom graph to my axis of revolution. And that's my inside radius, and that's little r, and that is x squared. So here is what this should look like. My volume is going to equal pi times the integral from 0 to 1 of outside radius squared minus inside radius squared. So let's clean that up a little bit. So that's going to be the integral from 0 to 1 of, well, that's x minus x to the 4th. So let's see if we can do that math. I don't think this is going to be too scary. There's our formula there. And so this is going to be x squared over 2 minus x to the 5th over 5. Don't forget we have a pi in front of all of this, and we're going from 0 to 1. So this is pi times 1/2 minus 1/5, and then minus, if we plug in the 0, we just get 0. So I don't really need that. And so I'm going to get 5 minus 2 3/10 pi. That is the answer to that. So there you go. I'm going to do your cookie dough lesson tomorrow, and I'll help you with this. This is a really neat application of calculus. So I'll see you guys tomorrow.